Hey guys, what's up? It's me. It's Stevie Stroh, the original gamer Stevie Stroh. Full birth name Steve Strobridge, and we are here. We are back for a long overdue. And by the way, I've got my own personal Coco cat with me here right now. This is Mr. Gizmo Man, sitting here chilling on my lap. But we are here, and we are here for a long overdue chapter in Programming in Basic on the Color Computer. And we're going to pick up where I left off. In September of 2017 was the last time I touched this, which is, crikeys, going on a year ago, definitely 9 months ago is the last time I touched this video, and I don't remember what happened. I think I had a problem with the emulator or with my recording software. Something happened the day I wanted to make this video, and it just pissed me off, and I rage quit, and I just haven't had time to come back. But we're here, so enough about that. So we're on to chapter 27. And chapter 27 is called Managing Words. And it says here, in the last chapter, you used arrays to manage numbers. Here, you'll use arrays to manage words by editing, updating, and printing an entire essay. And I love the little pictures here. Here's the dude kind of lifting some weights, working out, just flexing his muscles. And then it says here, to start with a simple list of words. How about a shopping list, right? And so in this shopping list here, there's 12 items. So we have eggs, bacon, potatoes, salt, sugar, etc. through 12. And then it says, assign each word to a subscribed variable. This time use a subscribed string variable. For example, for the first 3 items, say S string 1 equals eggs, S string 2 equals bacon, S string 3 equals potatoes. And then it says if you want to see the items, then print them by saying print S string 1, comma S string 2, comma S string 3. By the way, the commas would print them in columns. And so it's kind of showing you here without writing a program how you could just demonstrate how you could set a few strings into memory, and then how you could print those strings out in a particular order. So on that note, the program that it's going to ask us to do here is to go ahead and dim 12 strings, provide the text for those strings in the data statements on line 10 and 20, 10, 20, and 30, excuse me, and then starting on line 40, 50, and 60, we're going to read in all of these strings as S string 1 through S string 12, and that will read in the 12 different items into 12 different string array variables. And then last but not least, it is going to print out the word shopping list and then print out all 12 items of that list. So let's see what that's going to look like. Now, what I did in more recent versions of this video series, I got a little bit smarter, and rather than having you guys watch me, and I still deal with the frickin' emulated keyboard issue, but instead of having you guys watch me type and listen to me think out loud, I got smart and I started typing them in advance, so we don't waste valuable video time with me just typing, because literally I'm typing the same crap that's in the electronic book that you could type yourself. But here's that program exactly as it's listed in the chapter. So we have dim S strings 12. Here's the data items for the 12 items in our shopping list. Here they are, starting with eggs, ending on juice. Here's the 12 times we're going to read those into an S string array. So S string 1 would be eggs, ending up on S string 12 being juice. Once we've read them in, we're going to print the word shopping list, and then we're going to go through a count loop of 12 and print out all 12 of those items. So let's run it and see how it works, and then bada bing, bada boom, there it is. Those 12 items that we put into data statements, we read each one into a different string array, and now we have them, and now we can print them out in sequential order or random order or any other order. But just getting back to what happened here, we started with data. The data statement says we're going to define some data for you to read in. So we have eggs, comma bacon, comma potatoes, comma salt, right? And each one of these, because it's not numeric, and because we're reading it in as a $sign, it's automatically being assumed to be text variables, so we don't have to necessarily wrap quotes around them like when we're printing it. The computer is going to assume that these are text pieces of data to read in. The comma is kind of the delimiter or the separator for these different pieces of information. And so this now becomes a one-dimensional array. So S string 1 is one piece of text, S string 2 is a second piece of text, and so on. And then we're printing those 12 pieces of text out from 1 to 12. Does that make sense? Well, I hope so. Okay, so now we're going to go back and look at the good book here and see what's next. Now it says do-it-yourself program 27-1, add some lines to the above program so you can change any item on the list. And I think I did that. So we'll go back, and that might be the program that I am calling 27-1. 27-1, whoops, I spelled it wrong because the frickin' real keyboard doesn't type the way a Cocoa keyboard types. Now I have to wait for that to time out. I have to spell properly. Load 27-1, program number 1. Let's list this out. 0 through 90. And the frickin' dashes aren't coming out. Alright, so we start off with the same thing. We then say eggs, bacon, lettuce, tomato. So the first 90 lines of the program are exactly the same. Let's list 91 through infinity. And but now, now I've added a line here. I've printed that line 32 times 13, so I've skipped 13 lines down. And I said, which item would you like to change? And this is all custom code because this is a DIY, so they're not telling you exactly what to do. They're leaving it up to your interpretation. And so I'm printing on a certain line on the screen, 13 or 14 lines down. I'm putting on the screen, what item would you like to change? I'm inputting a variable, a numeric variable called I. I do a little bit of validation checking here if you're out of range. So if you're less than 1 or you're greater than 12, then I'm going to go right back here and just ask you to do it again. If you do specify a number, then I'm going to print on line 14, what is the new item? And then for the new item, it's going to say, okay, so if I picked 4, it'd say new item 4. And then it would say, okay, now I'm going to input a new string. And I'm also doing a little bit of fact checking, where if you're double quotes, meaning empty, if you put in here nothing, or if you put in text that's more than 30 characters, which is longer than it'll fit on the screen, then I'm going to go back to line 130 and ask you again. However, if you do enter some valid text, I will then take whatever number you entered here for your input. So if you entered 4, I would replace S string 4 with the new string you just input. Then I go back to line 70 that lists out your shopping list. So this was all, you know, I had to make this crap up, right? So here's your first shopping list: eggs, bacon, potatoes, salt. Let's say you got high blood pressure and you don't want salt. So let's go to number 5, new item 5. We're going to put in Mrs. Dash, which is a salt alternative. As soon as I hit enter, boom, item number 5 has been replaced with Mrs. Dash for those of us with high blood pressure. Let's say you've got high cholesterol. You notice the theme here: as we get older, we seem to have lots of health issues, right? So let's say you got high cholesterol and you can't have cheese. So we're going to put in line number 10, new item for cheese. We're going to put in tofu. I have no frickin' idea why, but let's just pretend I know what I'm talking about here. So now we're going to put a slice of tofu on our sandwiches instead of cheese, and that'll taste real good. So let's say now you're also lactose intolerant. So now we'll go to line number 9, and now we're going to put in, we're going to say, well, we're going to take some soy milk instead of milk, right? And now I've just changed item number 9. I changed the wrong thing. I don't know what the heck line 5 was, but I just added Mrs. Dash. So number 4 instead of salt, maybe that was sugar. So for 4, we're going to say 4 is Mrs. Dash, and then 5 was probably sugar. We're going to say, you know what, we don't want to get diabetes and crap like that too. You notice the theme here, medical concerns. So in this case here, instead of sugar, we're going to say we want all natural stevia, which comes from a frickin' leaf and it tastes like cat piss, but it won't give you diabetes, kids, right? So now we got the stevia. I might have spelt that wrong. Don't really care. All right, everything else here is, well, you know what, eggs, high in cholesterol. So let's change those. So item number 1, we're going to call this egg whites. And then number 2, bacon. We're going to say turkey bacon. Healthier, right? Potatoes, I guess, okay, lettuce, tomato, bread, soy milk, tofu, fish, juice. Okay, this is a healthy shopping list. This is perfect for taking to Whole Foods, right? So what are we doing here in our program is that we are typing in a number, and the number is between 1 and 12. So if I type in 13, sorry, idiot, that won't work. If I type in 0, sorry, idiot, well, that, what if I type in -10, if I hit the right dash? That won't work, right? So when you type in a number, it's basically picking one of these 12 numbers in the array, letting you input something, and it's replacing that, and it's reprinting the list, right? So this is how you can modify basically a table of information stored in an array, already stored in memory, and just changing what's stored in one of those slots in the variables in your computer's memory. Awesome stuff, right? So now as we go back to the big book, and the good book as I like to call it, now it's asking for another program, do-it-yourself program 27-2. It says use a program to use an array to write song lyrics, and it wants you to enter in 4 lines of text, and then it's going to go through and do something, right? So I think that is which program is this? This must be now 27-2. Let's see if that's the one, and we're going to run this son of a biscuit here. Okay, enter 4 lines. Hi, my name is who, my name is what, Chicka Slim Shady. Alright, so this is your song. Hi, my name is who, my name is what, my name is Chicka Slim Shady. So what line would you like to change in your song? And was this a do-it-yourself? Oh, actually, so the do-it-yourself, add some lines so you can revise any line. So type 4 lines saying this is your song, and then it wants you to be able to change your song. So my name is, hi, my name is Antonio Montoya. 20 years ago you killed my father. Too long. You killed my father. And then line 4, prepare to die. Alright, hi, my name is Antonio Montoya. You killed my father. Prepare to die. Right? So these are 4 different pieces of text in a variable. What does this program look like? I don't remember. I wrote it 9 months ago. So let's list through 100. So we're dimming 4 strings. We're clearing the screen. We are printing out 4-line song maker. We are saying type in 4 lines. We're inputting 4 things. So we're importing x1, x2, x3, x4. They're all strings. So I have a string 1, a string 2, a string 3, a string 4. And then I say, well, this is your song. And then I do a 4x equals 1 to 4, and I print all 4 things out. And then this 101 through infinity and beyond. And then from this point here, this is, I guess this is the part I made up from scratch, where I said enter the line you want to change. I'm going to input L for line number. I do a little bit of validation here. If you're less than 1 or greater than 4, then go back and say, hey, idiot, put in a valid number. And then I skip a line and say, well, what is the new line? So if I pick line 2, I'm going to input L string. Again, a little bit of fact checking here, making sure it's not blank, making sure it's not too long because I don't want it to wrap off the screen. If you're too little or too much, I'll go back and ask you again. I will then replace a string L with your new line string. I'll go back to line 50. That will print out the list, right? So again, 4 lines. She loves you, yeah, yeah, yeah. She loves you, yeah, 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 etc. Right? So here's my song, right? She loves you, yeah, 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 yeah. Repeat, rinse, lather, repeat. Number 1, she just wants to be friends. 2, which means no sex. 3. Lots of cold showers. Yeah. Alright, so here's your new song. She just wants to be friends, which means no sex. Lots of cod showers, showers with fish. Talking about lots of cold showers. Yeah. I don't think the Beatles ever wrote a song like that, but at least they could sing better than me. So that was Do-It-Yourself Program 27-2, manipulating string variables in an array and then reading them in first or inputting them in a series and then going back and randomly changing the series of what you were supposed to do. Again, that program, not too long, right? But it achieves the goal. So last but certainly not least, or I'm not even sure if it's last but not least, but next on the list is this. Now that you've learned how to use string arrays, it will be easy to write a program to store and edit what you type. Type in this program here. So I'm pretty sure I also did that one and typed it in advance. So let's make sure that that's the one. I think because this is the last program on my disk, so either that was the last one or I just even stopped typing in. So WordProc is the next program, and this one goes to line 160. Where does mine go? Mine goes actually to, well, maybe I think I couldn't read the 6 and I typed it as a 180. So I think I've written the same program that's in the book. Let's find out. Type in a paragraph, press / when finished. This is a paragraph, and I think it's pretty awesome. How about you? Okay, now what does it say to press /? Okay, so it says your paragraph is, this is a paragraph, and I think it's pretty awesome. How about you? So everything I typed, it stored in a string and it reprinted my string. But how did it do that? I don't remember, again, because I wrote this 9 months ago, but I think it's actually here in the good book. So let's go back and look at this. So first thing we do is we cleared 1,000. So we cleared 1,000 bytes of memory for string space. We then created an array to store up to 50 characters. We then said, here's our starting message here. Type a paragraph, press / when finished. And then I said x equals 1. So we've defined a variable, starting this variable off on variable number 1. And then here's my loop starting on line 40. A string equals in key string. We're scanning for a key press. Line 50 says if a string equals nothing, double quotes, meaning no key is pressed, well then just go back to 40 and just keep looping and waiting for us to press a key. Line 60 says print a string. So whatever I typed, it's going to immediately display on the screen. Line 70 then checks to see if I pressed a specific key. It then says if a string equals quote / quote, then go to line 110, which clears the screen and prints out my paragraph. Line 80 is now storing the text. So it says a string x equals a string x plus a string, which is kind of funky, right? Because x started off as 1. And so as I continue to type, I am adding more to the same string. So a string 1 is where I started from. Because I didn't type in a period, everything is in a string 1. However, if I was to type a period, meaning I ended a sentence and I had more than one sentence to my paragraph, it would actually increment the value of x by 1 and start a string 2, and then until I pressed a period, then a string 3, etc. I didn't even realize that because this isn't my program. I just did it from the book. But let's try it again. And let's make sure my listing is the same as their listing, other than my 180 was a 160, but that's fine. Doesn't matter. I'm not going to resave it anyways. But when I do this, okay, this is the first sentence, period. Okay, this is the second sentence, period. This is the third sentence, period. And so on. Period, enter, slash. And so now it printed everything back. However, if I want to see so that the variable x should be at least 4. So it started at 1, I typed in a period, it incremented to 2. I typed in a period, it incremented to 3. I typed in a period, it incremented to 4. So if I say print x, actually because every time I typed a period it's already on 5, which makes sense. So now if I say for loop equals 1 to 4 colon print, what the hell were the strings here? A string LP colon, where the hell is the damn keys, colon next. These are my 4 things. So A string 1 is this is the first sentence, A string 2 this is the second sentence, A string 3 this is the third sentence, and so on. So if I was to say print A string 1, it should just say this is the first sentence, right? Print A string 2, this is the second sentence. So I see what the program is doing here. I didn't even realize that when I typed it in 9 months ago, to remind you all how long it's been since I've done an episode in this series. But yeah, so every time I type in a period, I increment the value of x. So what's happening here is that the string array of A string 1, it's the same string, but the string keeps getting longer. So as you keep typing, it adds that letter to the end of the string, making the combined string text kind of cumulative or additive, and it will keep adding letters to that first string array until you press a period, and then it will increment that, separating each sentence of your paragraph into a separate string. So that's kind of cool. So then again, we could get back to something like my earlier program. Once you've listed your sentences, we could say, well, which sentence do you want to change? Input a number, change that string, reprint the paragraph, and you could just do this ad nauseum, but I'll spare us that. So it says to run the program, do this and see how it works. And it says, well, let's see how this program works. Well, line 1 clears plenty of string space, right? Clearing 1000. Line 5 saves room for an array name A string, and you may have up to 50 sentences. Line 30 makes x equal to 1. X will be used to label all your sentences. Line 40 checks to see which key you're pressing. If nothing, then it goes back to line 40. Or line 50 keeps going back, right? So line 60 prints what you press. Line 70 sends the computer to the lines that print your paragraph when you press the slash key. Line 80 builds a string label, numbering it with x. X is equal to 1 unless you press a period. Then line 80 makes x equal to x plus 1. So if you entered an R period, A string 1 will equal R. If your second letter is O, A string 1 equals R or RO. And then it says assume that when A string 1 equals roses are red and you press period, A string 1 equals the entire sentence roses are red. The next letter you press will be an A string 2. Line 140 through 160, print the paragraph. Do it yourself 27-3. Here's a tough one, but it can be done. For those intrigued with word processing, change above program so you can print any sentence and revise any sentence. You may need to review the Challenger program in Chapter 12. Our answer is in the back. And then it gets into printing. Hold on, I need to let my cat out. Come on, Mr. Gizmo Man. Let's go. Go. All right, so I was thinking that might have been the next one that I should have, could have done. And when I look on my disk here, I don't see anything after word processing. So this might have been when I started to have problems and rage quitted. So I don't have an example of the DIY to change this program, but it would be very similar to the other program I showed you guys where you could change the song lyrics, right? So similar concept. I'm just not going to do it right now. Not going to do it. Wouldn't be prudent. So now, since we are still talking about arranging things, it's also now adding to the fact that you can send information out to your printer on your color computer. And so in this case here, if you type, it says if you have a printer, connect it by plugging in the jack marked serial IO, turn on the printer, insert paper. The manual comes with the printer, shows you how to. Now it says do this, type in this short program. 10, input a string. 20, print number -2, comma, a string. And that was the color computer way to print to the printer. Print number -2. Matter of fact, this was the name of a column in Rainbow magazine, for those of you who remember, right? Based off of this actual syntax that Color Basic gave us, right? Print number -2 was how we printed to the printer. And then also another command in Basic would be called LLIST. So if you wanted to list out, and this is not stuttering, this is not keyboard repeating here, but when you LLIST, you're line listing your entire program to the printer. So if you wanted a hard copy of your program, etc., etc. And then it also says that if you press Shift 0, this is how you turn on your lowercase, for those of you who don't remember. So if I come back over here and I go to my doohickey here, so this is text, and if I do Shift 0, this is lower text, right? So that's how the original Color Computer 1 and 2 handled text, right? The lowercase text was just an inverse of the uppercase. However, if you had a printer, most of your printers would support lowercase, so if you printed this inverted text to a printer, it would look like lowercase characters. So I think that's what they're my printer prints lowercase letters, right? And so now here's another DIY program that I didn't do. And then, but we'll assume, and I'll tell you what needed to happen here. But for the DIY program, it says modify lines 140 to 160 to, rather than printing out your sentence to the screen, print your sentence to the printer. And so in that case here, which I still have it on my screen, I'll just show you and I'll tell you, but I'm not going to do it because it's pointless. I don't have a printer and I wouldn't waste the trees to do it. But in line 140 to 160, when it says print a string y, in front of the word print, you would just put print space number -2 space a string y. So rather than printing to the screen, it would print to the printer. If you wanted to be fancy, you can have it print to both as you're doing it. You could print it to the screen on line 150 and 155. You could print the same thing to the printer, so it would kind of look like it's outputting and printing and outputting and printing. You could get fancy with it. So you would just be putting the word print number -2 in front of that. And again, I just posted a video this morning saying, listen guys, I'm really sorry it's taking me so long to get back to this. I know it's taking me 2.5 years to finish this, and I don't know why. It just has, but this was me attempting to start it up again, and I looked at the date of the disk image. It was September of 2017, and I got as far as actually going through the book and starting to type everything in, because I was trying to get smarter with these videos and not have it be 40 minutes of me figuring out how to type on an emulator. I figured, well crap, you don't need to watch me type. Let's just talk about it rather than type it out. So I actually got enough into this where it actually typed all these in, and for some technical reason or something just pissed me off, and I didn't finish it that day, and for whatever reason it's taken me 6 months to get back to this. But here's the long overdue chapter 27, and as I mentioned in my video I sent out this morning, I am going to try to commit to finishing this entire book and all chapters this month in June. Today is June 19th, so we've got 11 days, right? 30 days in June, I think. I don't remember if it was June 31st. That might be a trick question. But yeah, so about 11 more days to finish. I don't know how many more chapters. Let's look and see how many more fricking chapters are in this frickin' book. So 27, and maybe we're gonna, chapter 28 I'm gonna need to do because I'm working on a game, and I think I'll show you guys that real quick too before I wrap up this video. But we need to be able to sort. And the reason why I need to be able to sort is that as we're playing our game and we get high scores, we want to be able to keep a high score table and have the top 10 list of whose people's initials have played the game and what scores they've gotten. That's the only reason why I care about sorting. There's probably other practical applications in the real world, but screw those people. We need this for games. So the next chapter, chapter 28, is going to be all about sorting. What else are we going to do? What are we not going to do as we continue through this? And that's a relatively short chapter. So next, analyzing, right? I said anal. So if you have more than 4K RAM, it will be an easy way to analyze information by giving each item more than one subscript. We can see it through different dimensions. Ooh, so now we're getting into two-dimensional arrays, which I don't remember if we've covered. Again, can spend 2.5 years. I've been working on this. Been 6 months since I touched it, so we might have. I see a V and a D, VD. So that would be another chapter. This is chapter 29, analyzing. What else are we going to talk about? The third dimension. Ooh, that might be a long one, so chapter 29 might be long. That's what she said. Are we going to do chapter 30? Are we going to skip chapter 30? Is 30 worth doing anything? Section 4, back to basics. Chapter 30, the numbers game. We'll get into exponents. How long is this crappy chapter? Trig functions. No, I'm not going to get into trigonometry. I think I'm going to skip this chapter because trigonometry, waves, sines, cosines. You know, if you want to know how to mathematically do triangles and rotate them, that's great. I'm not going to need that for any games I'm going to do, so I will probably skip this chapter because I'm not going to be able to explain it to you because I honestly don't understand it. Exponents, right? So like 2 to the 4th power, right? Those are exponents. Fix, I don't know, def functions. Maybe we need to talk about def functions. This is where we get into defining some stuff, and I think this is how you can get into loading assembly language concepts. I don't know. Let's summarize chapter 30. Square root. Computing a sine, computing a cosine, computing a tangent, computing an arctangent, computing a natural logarithm, computing a natural exponential, rounding a decimal to a whole number, and defining a function. I don't know if I even want to cover that. I've already got a headache just thinking about it. Chapter 31, it don't mean a thing if it ain't got that string. So strings. Strings, when you use it to create a string of characters, you can produce graphs, tables, and any other text display. Syntax of the strings is as follows. So this is probably helpful. So chapter 31 will probably definitely do. String. And we got some examples in here. And what else do we need to cover? Then we get into chapter 32, in one door and out the other. Input and output statements let you send data from the keyboard to the computer, from the computer to the TV, and from the computer to the printer. These functions are primarily used inside programs to input data and output results. So we have line input to a string variable. Line input X strings. What is your first name? Customize printing, print using. By now you know that you can print more than one way. Oh, like you can print formatted text. Okay, I remember that, like to print high scores and stuff. You can like do print number, saying you want to do a 4-digit numeric thing. That's kind of like formatting things in Excel now. So yeah, that's probably useful. What else is we going to do? So positioning, right? Device squad. So yeah, so this one's probably got some useful stuff in chapter 32. Chapter 33 is called a little bit of everything. So now we have let. Let is an optional term because older versions of BASIC you had to put the word let in front of everything. So you couldn't just say x equals 1, you'd have to say let x equal 1. The Color Computer Basic said screw that, that's completely pointless. However, if you want to use it because you're like trying to type in a program from a generic magazine, you could. Tron and Troff, right? So Tron is not just a movie. It actually stood for trace on, and it's a way to turn on debugging to see what's going on in your program. Timer, right? So timer is kind of the real-time clock in the computer. It is basically a 16-bit number that goes from 0 to 64K or 65535. So you can use the timer. I used to use the timer to help me randomize things depending on how long the computer was running, where it was in its time counter, and you reset the randomization based off the timer. You got less predictable stuff. So yeah, it's probably worth playing with. We'll look at that. I guess we can talk about hex and octal. although I'm not going to use them in any of my programs, but we could probably talk about them. So that's chapter 33. And then chapter 34, interesting, varpter, user, peek, poke, de-user. These are things I never got into, so I'll try to cover this chapter. I have no previous knowledge or experience of using these, but what I'll probably do is maybe read it and test it and try it. And if I feel like I can actually explain it with any level of proficiency, then I will. And if I can't, then we won't do it. And as far as what I'm going to be doing with my games, I wouldn't be using this anyways. But it's in the book. And by the way, you guys all know you could be reading this yourself, right? Section 5, odds and ends. What the hell? Oh, these are all the answers to your programs. All right, so we only have maybe 4 or 5 or half a dozen of these sections to do. Not that many. I'm going to skip a few because I just don't think they're that important. They're not important to me. They're not important to any games I'm going to make, so I'm probably going to skip them. But I have showed this off on a recent episode of our show, Coco Talk, but I will show it off to you guys here now. Wrong disk. So I need to switch my disk in my emulator. And I'll just give you a quick peek of a work in progress I'm doing right now with what the hell is going on here. I'm clicking on the wrong stinking thing. Media, floppy disk. Unmount the current floppy disk. Media, floppy disk, mount file. All right, so Cosmic Aliens is my current Coco project I'm already starting on. So when I do dir, I will show you fonts H. I don't remember the difference in these fonts, but function call error in 9001. I don't even know what the hell is going on with this frickin' program here. Dude, I don't know. Screw it. I'm not going to try to figure out why. We'll just load in fonts. I don't know what I was doing with, fonts H might have been the one that I had to merge. I had to create one that I had to merge. All right, so yeah, so one of the things I had to do for the game I'm working on right now in BASIC is I had to come up with new fonts that looked proper on the low resolution screen I'm using. The low resolution screen I'm using right now is P mode 1. It is like a 128 by 96 resolution, so all the pixels are doubled up. So it's a double wide, double tall, super big square blocky pixel. And the original fonts I wrote in a previous demo were really written for P mode 4. They look good in P mode 4. They didn't look good here. So I came up with a ultra tight looking font that looks good on a low res screen. So I had to redesign these fonts, kind of debug those, and then write a little routine to be able to display these fonts on the screen. So there's that. And then I've been working on my Cosmic Aliens game and the latest version right now, which is still a work in progress. I got more things to do, but I will just show you guys what I'm working on right now. Aliens 05, latest version. And it's, listen, this is in BASIC. There's no pokes going on here. It's going to be running slower than dog crap, but it's my little baby, and I'm going to see if I can't raise this bastard. So, it's getting the information. It's now preparing the screen for us to see, and then boom, here's the screen. Now, I don't think I plugged in a joystick, so I won't be able to show you off. But what I can do here is I actually can, with the joystick, move my little spaceship from left to right, and I can fire a shot. The graphics I drew with an editor that Paul Thayer gave me. So what you see at the beginning of the program is basically the screen from the editor where I created all these different characters. So those get loaded in, and as these little yellow squares start coming across, this is me getting these into arrays. So I'm using the get put function that I demonstrated around chapter 19 or so. And just for myself, I actually inverted them to kind of highlight them as I was going across, showing that I got everything. I designed 8 different aliens ships, and so every time you run it, you're going to get a different alien on screen. And so right now what I have going on here is some very simple logic that is randomly moving the aliens around on the screen. I can move left and right. I can fire one shot. The shot will leave the ship, make it to the top of the screen, then disappear, and then allow me to fire that shot again. So it kind of tracks it's in motion. It tracks when it's on the screen. It knows when it leaves the screen. It knows when I'm allowed to shoot again. I got that far. The next thing I'm going to do now is figure out how to get these guys to drop bombs. Parallel to that, I now need to figure out in my mind, and I'm just brainstorming this with a few people, is what's the best way to know when my laser beam has hit a spaceship? What's the best way to know when a spaceship has dropped a bomb? If the bomb hit me, what's the best way to know as my laser beam's going up if my laser beam hits a bomb? You know, so this whole thing I'm talking about right now is a concept known as collision detection. How am I going to handle collision detection? And I have some ideas, and I think I'm going to do it in arrays, and I'm going to create an invisible table and block this thing off into an imaginary grid and have these things all occupy only one location of that grid. And in this array, I'm going to store a value. If it's a 0, it's got nothing in it. If it's a 1, for example, it's got an alien. If it's a 2, it's got a bomb. I don't know. And so as I'm getting ready to put an object in one of these imaginary cells on this grid, I will look into the array and see what's already there. And so if it's a 0 and there's nothing there, I can say, all right, well, I can put this object here and it's got no conflict, it's got no collision with anything else. However, if I go to put a laser beam in a cell that has a number 1, which is a alien, I'm going to say, well, crap, I just hit an alien, so now I have to trigger the thing to hit the explosion to update my score and take that alien off the screen. If I hit a bomb, well then shoot, I got to blow up that bomb, I got to trigger an explosion, I got to stop the bomb cycle, take it off the screen. And so I'm thinking the best way for me to know when two objects occupy the same space, since I'm going to have different types of objects, is to make some type of an array and just compare what's there versus what's about to be there and make a decision. In the past, when I did games like this, I would usually just look for a pixel color and say, well, if it's all black in the background, then it's empty space. But if it hits any other color, then I hit an object, and I could use the kind of like pset or whatever the frickin' command was to look at the color of a pixel on the screen. But I think this is just too elaborate, and that's going to be too imprecise for me to know just because I hit a color. But a color of what? Is it a color of a spaceship? Is it a color of a bomb? You know, so I need something else, and I need this to be really lean and efficient and not have to put in a lot of math and comparative logic here for this to be able to even be somewhat playable and basic. Right now we can already see this is kind of slow, but this is the project I'm working on. So at the end of the day, I figured when I finished this series I would figure out what game I wanted to make. But on top of that, I ended up finding this game that I made for the Tandy 1000. I made it in Quick Basic. For the Tandy 1000, I found one of the versions that was posted to a bulletin board in 1989. I have a playable version of that, but I don't have the source code, so I don't remember how I made it. So now I'm trying to basically recreate it, and and maybe be a little bit smarter about how I make it now, especially since this version is going to be in graphics and the original version was in MS-DOS base text. So here we go. I actually finished a chapter in Programming in Basic. I don't remember how long it took or how long I've been doing this. Whatever, it's done. I did it. All right, so this will get posted today. Again, today is June the 19th of 2018. And my goal and my commitment and my plan is to finish the entire book this month in the next 11 days. And then continue working on Cosmic Aliens, as well as other things like starting assembly and working on projects and blah, 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 blah. So I hope you enjoyed this, and thank you all who have been watching these videos and giving me comments and feedback and encouragement. Hopefully I will end up not disappointing you. So I have been the Original Gamer, Stevie Stroh. This has been another chapter in Programming in Basic on the Color Computer. I hope you've enjoyed it. If you don't already know about our Color Computer website, it's imacoconut.com. Frickin' wife talking on the phone in the background. Frickin' wife. So imacoconut.com is a website I created to create links to all kinds of color computer crap for you to discover. And cocotalk.live is our weekly live talk show about the color computer. It's every Saturday at 2 p.m. Florida time. If you don't know about that, you might want to check that out too. So a couple shameful plugs there. All right, guys, I'm out of here. Coco forever. Peace out. Bye-bye.